Did you know that some of our products have GPIO pins? That means you can use them in your electronics projects just like you would use ESPs, Arduinos, and all the other dev boards out there. Currently, we offer 3 products with GPIO pins. The oldest one is RBM33G. It can provide up to 6 GPIO pins, 2 voltage out pins, and it has several other interesting features that you can look into yourself. I want to focus on the newer not embedded LTE4. They both have 6 pins that you could easily access, but not all of them are usable for input-output. With the regular NOT, you get 1 ground pin, then 2 analog input pins, 1 digital input pin, and 2 digital output pins. The not embedded LTE4 is much smaller and has an eSIM for cellular connectivity, but it does cut back on other NOT features, including the number of useful pins. 3 of them are just ground, and then you have 1 analog input, 1 digital input, and 1 digital output. The NOT series do not provide a simple voltage out pin to feed other circuitry. This protects them from some user errors that could affect their correct functionality. So most likely you will want a power supply that can feed both the NOT and any sensors or relays that are connected to the GPIO pins. Now, you also have to respect the technical specifications of the pins, so let's quickly go over those. The analog input pins can accept a pretty wide voltage range, so you can take readings from various sensors. The NOT accepts input up to 60 volts, and the NOT embedded can accept up to 24 volts. The digital input pins can have some slight differences between the versions, but you can safely assume that 0 to 1.2 volts will be considered as a digital 0, and 1.5 to 2.5 volts will be a digital 1. However, the not embedded can accept digital input all the way up to 24 volts. Now, when it comes to the digital output pins, they are designed as open drain type. So they do not output any voltage. They send a digital signal by connecting or disconnecting the pin to the ground. This lets another circuitry detect the input by observing a voltage drop. Both NOTs can dissipate 0.48 watts in this manner, and it is recommended to not exceed 24 volts or 0.5 amperes with continuous operation. For brief signaling, you could go a little higher in amperes or volts. So overall, the not embedded LTE4 is safe to use with 24 volt circuitry. Over here I have a small example that makes use of a little 12 volt fan and a 12 volt temperature sensor. This simple circuit consists of a voltage converter that provides us with 12 volts and a tiny relay. The analog output from the sensor goes straight to the NOT, while the digital output from the NOT will trigger the relay and turn on the fan. As you can see, if I hold the sensor in my fingertips, it heats up and then the fan is turned on. And when it cools off, the fan is turned off again. The software logic to handle this behavior could be handled in many different ways, especially since this could be connected to the internet either through a cellular connection or through a regular Ethernet port. But in this case, we are running a simple script. The readings from the pins can be taken in the IoT GPIO section. You can see the analog pin is currently receiving 651 millivolts. Then the digital output pin is off and it could be toggled by a simple set command. Now, if we look at this script and the scheduler, we can see this script is executed once every 5 seconds. It takes the current analog input value in millivolts and performs a simple calculation to derive the temperature in degrees Celsius. Then when the temperature is about 25 C, the output pin is set to 1, turning on the fan. The calculation is pretty simple and is determined by the sensor manufacturer. In this case, there is a 500 millivolt offset, and the temperature reading is supposed to be achieved by simply dividing the reading by 10, but I am adding +5 in the end for calibration purposes. What you typically find with cheap temperature sensors is that they can be off by a few degrees, but you can use your own thermometer to calibrate. Since they are designed to be used with a linear temperature calculation, you should be able to just add or subtract a few degrees to achieve better accuracy. Anyhow, this is one example of how you can make use of the GPIO pins in our devices. Maybe you have built something better using the NOT or RBM33G products. Let me know in the comments. Also, I am thinking about using the NOT embedded LTE4 for some hobby project with remote controls or monitoring. Maybe you have some good ideas of what I could be building using the available GPIO pins. My number one concern is that I need more pins, and I can't provide a clock signal for a simple shift register. But I suppose I could use a cheap MCU that listens to the signals from our digital output pin and translates them into commands for its own GPIO pins. What do you think? Would that just be silly, or should I try it?